morning students. Today class transformer. What is a transformer? Which principle working for transformer? What are the important applications of a transformer? Transformer is an electrical device which is used to varying the magnitude of alternating voltage. Which principle working for transformer? Transformer works for the principle of mutual inductance. What is the mutual inductance? The phenomenon in which the EMF induced one coil due to change of current in another coil is called mutual inductance. Now, for example, in transformer, the EMF induced in a secondary coil, the rate of change of current in primary coil. So, this phenomenon is called a mutual inductance. So, students, what is the mutual inductance? The EMF induced one coil due to change of current to the another coil. This phenomenon is called a mutual inductance. So, which principle working for transformer? Transformer works on the principle of mutual inductance. So, transformer is an electrical device which is used to varying the magnitude of alternating voltage. What are the important applications of a transformer? A small transformers are used in radio receiver, telephone, loudspeaker, and also used in voltage regulator circuits for television. These are main important applications of a transformer. A small transformers are used in radio receiver circuit, telephone, loudspeaker, and voltage regulator circuits for television. So, this is a transformer principle and applications. So, now here the question may be in examination. So, describe construction and working of a transformer. Now, this is a transformer. This is a diagram for transformer, rectangular box. There are two coils are there in a transformer, P and S. P is called a primary coil and S is called a secondary coil. A same copper wire wound several turns in primary and secondary coil of a transformer. So, the same copper wire, the fine quality of copper wire wound several turns in primary and secondary of a transformer. Now, P is called a primary coil, S is called a secondary coil. The alternating voltage applied in primary and output voltage taken across the secondary coil of a transformer. The output voltage taken across the secondary of a transformer. And soft iron kept inside the transformer between primary and secondary coil of a transformer. So, this is a construction. A transformer consists of two coils P and S. P is called a primary coil and S is called a secondary coil. The same copper wire wound several turns in primary and secondary coil of a transformer. The input alternating voltage applied input of the primary of the transformer and output voltage is taken across the secondary coil of a transformer. A soft iron is kept inside the transformer between primary and secondary coil. This is a construction. So, what is the working? Now, the alternating voltage applied in primary coil. The alternating voltage is applied where? Primary coil of a transformer. The current changing per primary. The change in magnetic flux linked with a secondary coil and EMF will be induced. The induced EMF appear where? In secondary coil. So, the EMF induced in the secondary coil, due to the rate of change of current in a primary coil, this phenomenon is called mutual inductance. Therefore, transformer works on the principle of a mutual inductance. The alternating voltage applied in a primary of a transformer, the change in current in primary and EMF will be induced in the secondary coil. The output voltage across the secondary coil of a transformer The output voltage of a transformer depends on applied input voltage, number of turns in primary coil and number of turns in secondary coil. On what factors the output voltage of a transformer depends on? The output voltage of a transformer depends on applied input voltage, number of turns in primary coil, number of turns in secondary coil. Now NP be the number of turns in primary coil. NP symbol, number of turns in primary coil. NS be the number of turns in secondary coil. Now students, there are two symbols are there. One is NP and NS. NP is a number of turns in primary coil. NS is a number of turns in secondary coil. So now VP and VS. VP and VS. VP and VS be the input and output voltage of a transformer. Students, now your four symbols are there. First one is the NP, number of turns in primary coil of a transformer. NS is the number of turns in secondary coil of a transformer. VP, input voltage of the transformer. VS is the output voltage of the transformer. The four symbols is very important. So after capital T is nothing but turns ratio. Turns ratio means T equal to NS by NP. NS by NP. So capital T, this symbol which represents turns ratio, NS by NP. For example, NS, number of turns in secondary coil, so maybe 8 turns. NP, number of turns in primary coil, maybe 4 turns. So what is the ratio? 2 by 1. So the turns ratio 2:1. So students, you observe this point here. Capital T is a turns ratio. The turns ratio T equal to NS by NP. NS is the number of turns in secondary coil. NP is the number of turns in primary coil. Now example, 8 turns in secondary coil of a transformer, 4 turns in primary of a transformer. So now T equals 8 by 4, so 2 by 1, the ratio 2:1. So now also equals Vs by Vp. Vs by Vp. Vs is the output voltage of a transformer. Vp is the input voltage of a transformer. Now mathematical formula here, capital T equal to NS by NP equal to Vs by Vp. Now if T greater than 1, T greater than turns ratio T greater than 1, what happened? NS greater than NP. If T greater than 1, what happened? NS greater than NP, the number of turns in secondary coil is greater than number of turns in primary coil. Then what happened? Output voltage. So Vs greater than Vp. So here T greater than 1, NS greater than NP, then what happened? Output voltage, Vs greater than Vp, output voltage is greater than the input voltage. Output voltage is greater than the input voltage. Such a transformer is called step-up transformer. So what is a step-up transformer? Output voltage, Vs is the output voltage. The output voltage is greater than input voltage. Such a transformer is called a step-up transformer. So step-up transformer used to production of X-ray in medical hospitals. So what are the important applications of a step-up transformer? Step-up transformer used to the production of X-ray. So what is a step-up transformer? Output voltage is greater than input voltage. Such a transformer is called a step-up transformer. And point 2, if T less than 1, if T less than 1, NS number of turns in secondary is less than the number of turns in primary, then what happened? output voltage. So Vs less than Vp. Output voltage is less than the input voltage. Such a transformer is called step down transformer. So step down transformer used in electrical welding. So what is the application of step down transformer? Step down transformers are used in electrical welding. Now here two conditions are there. If P greater than 1, Ns greater than Np, Vs greater than Vp, output voltage is greater than input voltage, such a transformer is called a step-up transformer. And second condition, if P less than 1, Ns less than Np, so Vs less than Vp, output voltage is less than the input voltage, output voltage is less than the input voltage, such a transformer is called step-down transformer. What are the important applications of step-up and step-down transformer? Step-up transformers are used for production of X-ray. Step-down transformer used for electrical welding. So after PO output power, PI input power. PO is the output power, PI is the input power. For ideal transformer, so output power equal to input power. For ideal transformer, output power equal to input power. So PO equals PI. Now for electrical power formula, P equals V into I. Electrical power formula, P equal to V into I. P is a voltage or potential difference. I is a current. So voltage into current, that is called electric power. So P equal to P equal to VI. So input power PI, VPIP. Input power PI equal to VPIP. Output power PO, so VSIS. Input power VPIP. Now friends, you observe this formula here. P power equal to V into I. The output power means output voltage and output current. Output voltage what? Vs. Output current Is. Therefore, PO output power equals VSIS. And input power PI, input voltage Vp and input current Ip. So VPIP. So VSIS equal to VPIP. Or one more formula, Vs by Vp. Vp take denominator left side. So Ip by Is. So Vs by Vp equal to Ip by Is. For ideal transformer, output power equal to input power. So PO is the output power, PI is the input power. So VSIS equal to VPIP. So Vs by Vp equal to Ip by Ip by Is. Now the finally efficiency of a transformer. Efficiency eta equal to, so output power by input power into 100. So eta is a efficiency of a transformer. So PO by PI into 100. PO is the output power, PI is the input power. So this is the construction and working of a transformer. Now power loss in a transformer. So this point is very important in examination. 2 marks or 3 marks question. Every year the question may be arranged here a 2 mark or 3 marks. Last year 3 marks question. So now this year March 2013 examination 2 mark question. Power loss in transformer, or mention the source of energy loss in transformer. Sometimes a transformer power may be lost. At what condition power may be lost in a transformer? Some important observations here, important So source of energy loss in a transformer. In a transformer, two coils are there, primary and secondary coil. The coil which offers resistance, heat is produced. So after, transformer day by day, power may be lost. So the first one is loss of energy due to resistance. Is very important, this point. Loss of energy due to resistance. Students, now this point is very important. A loss of energy due to resistance. The resistance offered in primary and secondary coil of a transformer, then what happened? Power may be lost. So how to avoid this one? Using thick copper wire. So now the first source, loss of energy due to resistance. So in examination you answer only this sentence, what? Loss of energy due to resistance. And second point here, loss due to flux leakage. In a transformer, some gap between primary and secondary coil of a transformer, certain gap is there between primary and secondary of transformer. Day by day, power may be lost in transformer. So that is the second one, loss due to flux leakage. And 3, loss due to eddy current. A soft iron is kept inside the transformer between primary and secondary coil. The current, induced current on the surface of the iron core, soft iron core, is called eddy current. So in a transformer, eddy current may be increased, power may be lost. That is a loss due to eddy current. How to minimize eddy current in a transformer? A laminated soft iron core used in a transformer, eddy current may be minimized. Eddy current can be minimized. Now your answer what? Loss due to eddy current. And fourth one, loss due to hysteresis. Which magnetic materials are taken for transformer? Ferromagnetic materials. Ferromagnetic materials taken to cycle of magnetization is called hysteresis. That is the previous lesson. Hysteresis. So wide hysteresis area, the specimen, a lot of energy may be lost. Narrow hysteresis, the specimen, a small energy may be lost. So loss due to hysteresis because ferromagnetic material, soft iron, is taken where in transformer. So these are 4 important the source of energy loss in transformer. Student, you keep this point here. The 4 points is very important. So I will repeat one more time. Loss of energy due to resistance. Only in examination you mention this sentence, loss of energy due to resistance, loss due to flux leakage, loss due to eddy current, loss due to hysteresis. Without explanation, only you mention this sentence. Mention the source of energy loss in transformer. Sometimes maybe the questions arranged in 3 mark question, sometimes maybe 2 mark question. So in 3 marks you mention 3 points. 2 marks must mention 2 points. So loss of energy due to resistance, loss due to flux leakage, loss due to eddy current, loss due to hysteresis is very important your examination point. So you read number of times, so you understanding, mention the source of energy in transformer.